Hey everyone, welcome to homework 4.17. So this homework goes over looking at where the graph or how to graph when we have the vertex form. So you have a test on Monday, so you need to make sure that you do this carefully and study. And I'm also going to post a second video just to go over a couple of things and review some things. So here, the graph of a quadratic function f. Andre uses this expression, Noah uses this expression. Do you agree with them? Well, what I'm going to do is look at this equation and make my own equation. So I'm going to say f of x equals, using my vertex form, x minus 5 minus 7. Because I have a positive 5 here, we know that our equation is x minus h squared. Right? And so that tells me that, that minus is part of the equation, and I have a positive 5 here. So I actually do not agree with either of them. This one is wrong because this part should be minus 7, and the second one is wrong because this part inside should be x minus 5. It says here are the graphs of x squared minus 5, and parentheses x plus 2 squared equals 8. How did the three graphs compare? So you need to write something here to compare them, right? So x squared is with vertex on the origin. X squared minus 5 moves or translates 5 units down, and x plus 2 squared minus 8 moves 2 TWO 2 units left and 8 units down. All right, it says compare the graphs of x squared and x squared minus 5. What role does the minus 5 play in comparison? So it translates the vertex down 5 units. And then it says, compare the graphs of x squared and x plus 2 squared minus 8. What role does the plus 2? So it moves the vertex 2 units left. All right, so number 3 says, which equation represents the graph of y equals x squared plus 2x minus 3, moved 3 units to the left? When we're moving 3 units to the left, remember that means that we are adding 3. So we're looking for a place that we're adding 3, and we're adding 3 to x. And so we have to add 3 to x everywhere. This is the original equation, so I would add x plus 3 squared plus 2 times x plus 3, and then that minus 3 has to stay there. So that means that D best represents that shift. And what I would encourage you to do is go ahead and plug that into your calculator to see what you get. But remember that when we're moving 3 units to the left, we're adding 3 to x. If we were moving 3 units to the right, we would subtract 3 from x. All right, it says select all the equations with a graph whose vertex has both a positive x and a positive y coordinate. All right, so our vertex here would be 0, 0, so not that one. This would be 1, 0. Technically 0 isn't positive, so we're going to say no to that one. This would be 3, 2. Yes, positive x, positive y. 4, negative 5. Nope, not this one. This one is negative 2, 6. Not that one. Remember that plus 2 is deceptive because that's really x minus a negative 2. This one here would be 4, 3. So this one is positive. This would be 3, 1. This is also positive. Now these equations would have, right, they would be facing down or open down. However, they do have both a positive x and y coordinate. Number 5, the height in feet of a soccer ball is modeled by this equation, where time is measured in seconds after it was kicked. How far above the ground was the ball when it was kicked? 2 feet. So I don't know what it was on, but it was above the ground. And we see that there in the y-intercept. What was the upward velocity? That would be 50. Since we're talking about seconds and talking about feet per second. And then why is the coefficient of the squared term negative? And that's because it is the effect of gravity. Number 6, what is the vertex of the graph of the function? So first our vertex is 3, 6 here. So let's go ahead and plot that. 3, 6 is here. Now it's a negative coefficient, which means this graph is going down. So now I'm going to find the y-intercept. Now I can find the y-intercept in 2 ways. I can plug 0 in for x, or I can go ahead and put this into standard form. So if I plug 0 in for x, I get negative 3 squared, which is 9. Okay, so we'd replace this with a 9. But then I have that negative. So it's negative 9 plus 3 is, or sorry, plus 6 equals negative 3. So it can be 0, negative 3. Now we can check that answer by also putting this in standard form. So if I do negative x minus 3 times x minus 3 plus 6, it's important that you first go ahead and use your parentheses. So we're going to keep our negative out here. X squared minus 3x will be minus 6x plus 9 plus 6. Now I have to distribute this negative through everything in the parentheses. So negative x squared plus 6x minus 9 plus 6. This negative is only being distributed through the parentheses because that's all it's being multiplied by. So this plus 6 stays the same. Now notice when I add negative 9 and 6 together, I will get negative 3. So I've confirmed that that is in fact our y-intercept. Now remember, because our graph is symmetrical and it's facing downward, that means the other point will be equidistant also here at negative 3, so 6, negative 3. And now that I have another point, I can sketch a loose graph of what that quadratic will look like. All right, at 6 a.m., Lynn began hiking. At noon, she had hiked 12 miles. At 4 p.m., Lynn finished hiking with a total trip of 26 miles. So 12 miles, 26 miles. During which time interval was Lynn hiking faster? Explain how you know. So from 6 a.m. to noon, she hiked 12 miles. So that's 12 miles per 6 hours, which means she was hiking 2 miles per hour. Then at 4 p.m., Lynn finished hiking. So that's 4 hours later, right? She had finished hiking with a total trip of 26 miles. So total 26, but 26 minus 12, because that was, she originally did 12 miles, means that she did 14 miles in 4 hours. Automatically looking at this, this is going to be a larger number. We're looking at 3 1/2 miles per hour. So her time interval that she hiked faster was from 12 noon to 4 p.m. She was going 1.5 miles per hour faster. All right, Kieran bought a, oops, I think I moved this graph here. Kieran bought a smoothie every day for a week. Smoothies cost $3 each. The amount of money he spends in dollars is a function of the number of days buying the smoothie. All right, so amount of money is a function of days. So days is here, money is here. Sketch a graph of this function. Be sure to label the axes. So he buys a smoothie every day for the week. 1, 2, 3, 4, 5, 6, 7, 8. And then the amount of money he spends in dollars for that week is here. All right, so if he's buying each one and they're $3, at the end of a week, he would have spent $21. So let's go ahead and do this by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, so day 1, he has spent $3. Day 2, he spent $6. Day 3, he spent $9. Day 4, $12. Day 5, $15. Day 6, $18. Day 7, $21. All right, so now this is the graph, and it says describe the domain and range of the function. So the domain would be days which means we're looking at whole numbers. 0 to however long he continues to buy the smoothies, right? If we're thinking about maybe within a year, we might say 365. It does say for a week, so we're going to say 0 to 7. The range, however, is the output, and this is intervals of 3, or multiples might be a better word, actually, multiples of 3. Right? 3, 6, 9, 12. It can't be anything in between because each one costs $3 and he's not going to buy half a smoothie. All right, number 9, a deposit of $500 has been made in an interest-bearing account. So $500 is our starting amount. And now what is important to note is that these interest amounts are annual interest. So this is what we call nominal interest amount because it's annual, which means every year, but calculated monthly. So that means, if you remember correctly, we have to do something special with this. So interest means we're increasing. So this is 1.065, right? Or 1 plus 0.065. Now, that means if we're calculating it monthly that we're dividing this by 12. So we would write this as 500 times 1 plus 0.065 divided by 12. If you wanted to, you could actually calculate that, but you can leave it as this as well. And then to the power of 12, but also then to the power of 5, because we're doing that for 5 years. The next one then would be 500 times 1 plus 0.065 divided by every 2 months means 6 times a year. So 6 times to the power of 6, and then again to the power of 5 for those years. The next one would be calculated quarterly means 4 times a year or every 3 months. So this would be 1 plus 0.065 divided by 4 to the power of 4, and then times to the power of 5 rather, because we are doing it again for 5 years. And then lastly, semi-annually means twice a year. So 0.065 divided by 2 to the power of 2, and then to the power of 5. So you can write it like that. Now remember that when we raise a power to a power, we can also write this as 500 times 1 plus 0.065 divided by 12 to the power of 60. Right, so you can rewrite that exponent should you choose. All right, number 10, function h is defined by this equation, and then function k is defined by this equation. Complete the table with values of h of x and k of x when necessary round to 2 decimal places, so to the hundredth place. Which function do you think eventually grows faster? So you know that k of x will eventually grow faster because it is exponential. Now, we want to go ahead though and plug these values into our calculator and then go ahead and fill in our table. So let me go ahead and get our calculator up. All right, so I have my calculator now. I'm going to do 5x plus 7 is my one equation, and then let me move this so I can see my other equation is there something? Oh, okay, nope. 1.005 to the power of x. And I'm going to second table to see my values. Now, 1 is 12 for the first one, and 1.05, 005 rather, for the second one. And then for 10, we have 57 and 1 point, this is still very, very small, 1.0511. And then 50, so I have to tap it each time apparently to scroll down on this one. 50 is 257, and we're still, the other one is still smaller at 1.2768. Oh, it said 2 decimal points, so I would write this as 1.28, 1.05, and 1.01 if we were rounding it, right? And then we want to look at 100. So I'm going to show you now, you can go to second, table set, and we can change where we're starting, so I can go directly to 100. You can also change what it's increasing by, so just wanted to point that out while I'm here. So second table, I'm going to go back there to 100, and it's still 507, and the other one is still way smaller at 1.6467, so 1.65. All right, now notice, however, that we said k of x will eventually get greater. So let's look and see in our calculator how long that's going to take and then when that's going to happen. So I'm going to go to second, y equals, I'm going to graph. And our red line is the actually exponential line. So let's zoom out quite a bit here. Let's start with the standard view. And so I can't really see anything. This is going to be going on for quite some time. So I'm going to go to my window and I'm going to change my x max to 100,000. Ah, there we go. 5 is intersection. Sorry, y'all. My family is really out to get me. My cat just came in. He's knocking stuff off. Okay, so it appears that they intersect where x is 1,828 and y is 9,051. So 1,828. And so it doesn't happen for quite a long time when we get all the way up to the thousands. All right. So in thousands is where we finally see this. All right, these last two problems are park problems to help you prepare for park. And it says determine all the real roots of the equation. So roots is, I wanted you to see this because this isn't a word that our curriculum uses, but it's a word that the Park or the Cape might use. Roots is the same as zeros. It's the same as x-intercepts. So when they say roots, that's what they mean. So here, one x-intercept would be -7 for sure. Okay? So -7 is one of our x intercepts. The other thing we have to look at, though, is this one. So if we do x plus 7 equals 0, we got x equals -7. We know that that's true. But we also need to look at x squared minus 49 equals 0. And when that happens, I can add 49 to both sides. And I get x squared equals 49. Well, to get the square, I'm going to take the square root of both sides, and so x equals. What's interesting about this is it can equal both +7 or -7. We already have -7 over here, so it doesn't really matter, but we use this symbol plus or minus 7 to mean it could be plus or minus, positive or negative. So our other 7 would be another real root, or another 0 of the equation. All right, so that's the first one. And so there's two main points I want you to get from this. One is when we take the square root of a number, say 9, for example, this could be positive or -3. because -3 times -3 is 9, and +3 times +3 is also 9. And we use this symbol to designate that as both positive or negative, okay? And then the other thing is that when you are solving something like this, you can do what you always do and move this to the other side by adding 49 to both sides. So you get x squared equals 49, okay? Now, the next one says which statements regarding the function f of x equals -3x squared plus 18x minus 21 are true. Select all that apply. So when written in vertex form, it's which one of these is it? Now, I can find this out by converting all of these to standard form and figuring out which one matches. So this would be -3 times x minus 3 times x minus 3 plus 6. Again, I'm going to do my FOIL first. So -3 times x squared minus 6x plus 9 plus 6. Now I'm going to distribute my -3, so -3x squared plus 18x minus 27 plus 6. And so I would get -3x squared plus 18x minus 21, right? Because -27 plus 6 is minus 21. So A works. Let's try B. Now B, notice, is the same as this except with a -2. So if I were to change this last part here to -2, I would get -29. So I know that that is not true. This next one is very similar to the first one, except that it is missing the coefficient of 3. So we know that that is also not true. And then same thing with this one right here. So lastly, it says the vertex of f of x is located at 3, 6. So if this is our equation, then our vertex is in fact 3, 6. So this is also true. Okay? Extra credit. So I would love if you did the extra credit, but you definitely don't have to. But I think that these would help you think about some of these real world situations. So I'm not going to go over this because it's extra credit, but if you attempt it, even if you try it, and I can tell that you've tried it, I will give you extra credit added onto your test score that you take on Monday. All right, so this is extra credit for your test score on Monday. All right, again, I'm going to create a second video to go over just some things for the test that I strongly encourage you to watch. Your code word for today is candle. Candle is your code word for today, so put that at the top of your paper for extra credit. Happy homeworking and study, study, study.